sketch diagrams, let's deal with these two examples. These examples will guide you and help you very much. If sine 21 equals to t, express each of the following in terms of t without the use of a calculator. Now, what do I do? In this case, the first thing that I do remember is to draw a diagram. I need to sketch my diagram. So I'll come and sketch my diagram. You draw the two Cartesian planes there. You draw the four quadrants there. And then you come and place your diagram there, something like this. We'll assume this diagram is in the first quadrant. Why? Because t is positive. That means sine will be positive, and sine is positive in the first quadrant. So it's 90 degrees. It will be 21. Then sine, remember it's sine 21 equals to t. Therefore it's t over 1. So present it as a fraction. If it's a fraction, that means that is opposite and that is hypotenuse. So I'll come there. Opposite of 21 is t. Hypotenuse of that is 1. The next thing to do is to find my adjacent there. So how do I find adjacent? It will be x squared plus y squared equals to r squared. What is x? That's what I'm looking for, plus 1. T squared equals to 1 squared. That is x squared equals to 1 minus t squared, where x equals to square root of 1 minus t squared. So this is 1 square root of 1 minus t squared. Okay, having done that, now start solving. First one, A. This is my solution. A, which is sine 339. So sine 339, remember, this angle lies in one of the quadrants. But which quadrant? It lies in quadrant number 4. So in quadrant number 4, from our reduction, remember, this is also presented as 360 minus something. What is that? Minus 21. So 360 minus 21, I'll get 330. So I have to reduce that angle of that. So if I reduce it, I'll reduce it to 360 minus 21. So because if I place this in calculator, 360 minus 21, I have to get 339. So which gives me a minus sine 21, because in the fourth quadrant, sine is negative. Then from there, you know, sine 21 is t, so it will be minus t. And that's my answer. Then B, which is cos 69. Now cos 69, if we place in the calculator, we find that cos 69 will equals to, 69 will go to 90 minus 21. But now this is a cofunction now. So I have to change that to its cofunction. It will become sine of 90 minus 21. Remember, if I take angles along the y-axis from your quadrants to 70, that is 0, and 360 is 180. If I take angles along the y-axis, for example, I took 90 minus 21, immediately that will change to its cofunction. Then this lies in the first quadrant, so it remains sine 21, which will equals to 2. And the next thing there, the next question is C, which is cos 42. Cos 42, 42 is equivalent to 2 times 21. So that one becomes a double angle. So I'll come there and say this becomes cos 2 times 21. So it's a double angle. Someone can present it like this: 2 into 21. a double angle. I can either use cos, because a double angle for cos has 3 identities, so I can use any of the identities. So if I use the cos identity or the sine identity, let me use the sine identity, will be 1 minus 2 sine squared 21. Then it will be 1, this is the same as saying sine 21 squared, which is 1 minus 2 into what is that? T squared, which is 1 minus 2t squared. And that is our answer. Then getting to D. D is cos 21, which is straightforward, equals to cos 21. Remember, cos is adjacent over hypotenuse. So I'll take this from my diagram. So cos 21 equals to, adjacent to that will be 1 minus, square root of 1 minus t squared over hypotenuse, which is 1. 2, 1 minus t squared. That is the answer for that. Then lastly, which is D, which is E. In that regard will be sine 81. And if you see sine 81, it's like someone got 60 plus 21. So 60 plus 21, you get 81. So 60 is a special angle. Whenever you have these abnormal angles, try them out with a special angle. So you have 81, for example, we try to do the 60 plus 21 and still get to 81. For example, in this case, 69, we used 90. 90 is a special angle, minus 21. 42 is a double angle. So all these abnormal angles, what you do, you use your special angles. Try them, subtract, add, multiply, and then until you get to the right value of those abnormal angles. So sine 81 will be what? 60 plus the, so I'll substitute 60 plus 21, and then I will apply my double angles, compound angles, which is sine 60 cos 21 plus sine 21 cos 60. This is equals to sine 60 is root 3 over 2. Then cos 21. Cos 21 we already found it, which was root 1 minus t squared. That's plus sine 21, which is t, and cos 60 is half from the special triangles. And half, something like this. Then all I need to do is to simplify to the root, that is root 3. So root 3 times that, I can put the 3 inside because they are both square roots, so 1 minus t squared. That is over 2 plus t over 2. It can also be written as t, which can also be written as t plus root 3 1 minus t squared all over 2. If you want to simplify, but actually if you leave it like this is still fine. If you leave it like that, it's still fine. The next example in this case, if sine that equals to p and cos that equals to q, determine the following in terms of p and q. Now, the first thing that I need to do here is, let me write this down. Okay, continuing my solution. A says so for sine 48. So first thing that I need to find out is how do I get 48? How do I find 48? So from the information given, if I'm to look at this, if I add those two angles, I'll get 48. But how do I come to that? So I'll have to apply my compound angles, compound angle identities. Why? Because if I take this and that, I'll come up with my sine compound angle identity. So if I have sine 36 cos 12, and then I add that plus cos 36 sine 12. Remember, this is equals to what? P plus Q. So it will be equals to P plus Q, because this is P and that is Q. I hope we are together with that. Then the next thing that I have to do is now to apply my compound angles. If this is 36, 12, 12, then that becomes sine 36 plus 12 from your compound angle identities. And remember, still this is equals to P plus Q, which gives you sine 48. So in that regard, sine 48 equals to P plus Q. And that is the answer. The next one, which is B, is sine 24. Right. For sine 24, if I look at these angles, if I take 36 minus 12, I can get 24. But how do I get to that? Still, I'll come here and say sine 36 cos 12. If I subtract those compound angles, I'll have sine minus 12, cos 36 sine 12. But this is equals to what? That is P minus Q. Are we there? Okay, try to find that out. It will become sine 36 minus 12, which is equals to that. And then therefore sine 24 is equals to P minus Q, something like that. They should found that, okay? So the next one, which is C, will be cos 24. So how do I get cos 24? For cos 24, since I have sine 24, all I need to do is to draw a diagram. So I'll come and draw my diagram there, and then say this is my triangle, and this angle is 24. From the sine, the opposite of that, remember it's sine 24 equals to P minus Q. So if it's sine P equals to P minus Q, that means P minus Q over 1. So that becomes my opposite, that is my hypotenuse. Then opposite will be P minus Q, hypotenuse will be 1. Then I have to find my adjacent, which is x squared plus y squared equals to r squared. What is x squared is what I'm looking for, my adjacent, plus y squared P minus Q squared equals to 1 squared. So x squared equals to 1 minus P minus Q squared. I can't times that. I will leave it as it is, but I will take the other side, become negative. Then x squared equals to 1 minus P minus Q. Then all I need to do is to square root that. So x equals to square root of 1 minus P minus Q squared. Then I'll leave it like so. This adjacent therefore will be 1 minus P minus Q squared. So I'll come here and say cos 24. So cos 24, remember cos theta is equals to adjacent over hypotenuse, right? So cos 24 in that case will be equals to adjacent, which is root 1 minus P minus Q all squared over 1. So which will give you root 1 minus P minus Q